Okay, so I'm going to do some examples on section 1.20, gradients. On page 29, there's number 7. Number 7 says we have a line joining this point to this point, 7, comma D. So this is not a number, it's an unknown, it's a variable. The problem says it has this line connecting these 2 points has a gradient, which we use the letter M for that, a gradient of 1 over 2. And then it says find the value of D. So on these points, let's call this point 1 and this point 2. This is the x1, y1. Let's call this x value x2, and this will be y2. We have a formula for slope. Slope is rise over run, or the difference in y values divided by the difference in x values, which is the difference in y values. So we take the second one minus the first one, divided by the difference in x values. And here, if we're going to do 2 minus 1 here, we're going to do x2 minus x1 here as well. We could switch these points, but we have to be consistent in starting with the second point or starting with the first point. So if this is our formula, let's plug in the things that we know. We know that the gradient M is actually 1/2. So 1/2 apparently is second y value minus the first y value. Y2 here is D minus y1, which is 6, over x2 minus x1. x2 is 7 minus x1 is 3. So 1 over 2 equals D minus 1. Can't do anything there, but 7 minus 3 is actually 4. Let's multiply both sides by 4. Multiply by 4. 4 times 1/2 is 2. Something divided by 4 multiplied by 4 is just the original something, D minus 6. Let's add 6 to both sides. 8 equals D. So D equals 8. That's our answer. Ooh, I'm going to need more paper. Let's do number 8 as well. Number 8. Number 8 says we have a line joining -4, comma -1 to another point, -1, comma E. So here again, E is our unknown y value. This line has a gradient, M, of 2. Find the value of E. Find E. So same thing here, right? Gradient equals y2 minus y1 over x2 minus x1. The gradient here is 2, so 2 equals y2 minus y1. Oops, I didn't label them here. Let's do that. So x and y value of the first point, x and y value of the second point. y2 minus y1 is E minus -1. x2 minus x1 is -1 minus -4. Ooh. 2 equals E minus a -1 is actually E plus 1. -1 minus a -4 is -1 plus 4, which equals 3, right? just write that 2 back here. Forget about this. I don't want to make it too complicated. Let's multiply both sides by 3 to get e plus 1 on this side, and 2 times 3 is 6 on that side. Subtract 1 from each side gives e equals 5, right? I didn't write out all the steps there. I'm going to trust that you know how to get there. Then there's another one like it on the unit review on page 47, number 20. P, that's what it says. P is the point, P comma 15, right? Then we have another point, Q. That is the point -4, comma, Q. The line PQ has a gradient. The gradient is -2. Okay, I'll write this out once more. This is our formula to find the gradient of any line given 2 coordinates. This will be point 1 with x1, y1. This will be point 2 with x2 and y2. M, the gradient, they tell us is -2. So -2 equals y2 minus y1. So q minus y1 is 15. All right. x2 minus x1. x2 is -4. Minus x1 is p. So, okay, I was going to simplify that, but I can't. What are we going to do? What are we going to do? Oh, let's read the question. The question says, find an expression. Find an expression for Q in terms of P. What does that mean? We want to find an expression for Q, so Q equals something in terms of P. So Q equals this other expression that includes P, right? So our goal is to get Q by itself on one side. Okay. We've got this. We want to get rid of this fraction bit, so we're going to multiply both sides by -4 minus p. -4 minus p. I'm going to multiply. Okay. Expand. Yes, -4 times -2 is 8. -p times -2 is a positive 2p, right? Something divided by -4 minus p multiplied by -4 minus p is just q minus 15, right? This cancels this bit out, so we just left with q minus 15. We want q by itself, so let's get rid of this minus 15 by adding 15 to both sides. That gives us q on this side, and 2p plus 8 plus 15 is 23. So q equals 2p plus 23, and that's what they asked us to do. We found q in terms of p.